are in section 4 of Unit 6, and section 4 deal with logical reasoning statements, and negations. So by the end of this session, you should be able to identify and form true or false of simple statements and their negations. Statements. So we start with statements. Any group of words that give a fact about something is referred to as statement. For example, John came to school on Monday. The goat was allowed to graze on the field. Amma is taller than Do. Guide your student to note that each of these three preceding statements may be true or false. However, they give facts about somebody or something. A sentence which is either true or false, but never the two, is considered to be a statement. Now consider the following sentences. Who is dancing? What is wrong? What is going on? Send the pen back. Clean the board. Explain to students that these are not statements because they are neither true nor false. The first two, A and B, are questions. The third and the fourth are commands or instructions. So letters such as P, Q, and R are often used to represent statements. For example, P. So P is such that 6 belong to multiple sets of multiples of 3. Q is such that Accra is the capital of Gambia. So these are statements, and you use the capital alphabet to represent these statements. So the statement can either be true or the statement can be false. Whereas the first statement is true, but second statement, Accra is the capital of Gambia, is a false statement. So a statement can be true or false. Let us consider the statement. P. Desire is a brilliant student. You can guide your student to notice from the statement that there are students in general. B, they are brilliant students, and C, there is a particular student called Desire. So the universal set becomes students. There will be another set called brilliant students. Then Desire is a particular element in the brilliant students. So this is how your Venn diagram will look like. Venn diagram, which is general students, then the brilliant students, then Desire will be in this. So let's take these few questions. P. Decides that 5 is a prime number. Q. Kafu is a medical student. R. 9 is a perfect square, but 7 is not. So in this case, our universal will be numbers. Our P will be prime numbers, where 5 belongs to it. In question B, universal will be student. M will represent the medical student, and Kafui will be K, which belongs to the medical student. So Kafui is part of the medical student. In the question C, 9 is a perfect square, but 7 is not. So universal will be numbers. S represent the perfect squares. So 9 belongs to the perfect squares, and 7 is not part of the perfect squares. So universal S perfect square, 9 is part of perfect square, but 7 is not. So 7 is outside of the perfect squares. So we can also explain how you will guide your SHS 3 student to represent the following statements on the Venn diagram. T. Teachers are important workers. Mathematics are clever people. Mathematicians are clever people. Ellie is a mathematician. Though is a clever but not a mathematician. Casey is not a clever student or a clever person. So in this case, our universal will be all workers. Then T will be important workers. So we have all workers as universal. Then we have important workers as T. Sorry, important workers as I. I for important workers. Then we are saying teachers are important workers. So T will represent teachers. And these teachers will be within the circle for teachers will be within the important workers because teachers are important workers. So they are within the important workers. Thus, T is a subset of I. Rather, T will be a subset of I. So we can guide our students to identify the people as the bigger set contain clever people from the second statement. So for the second statement, we have P, which is mathematicians are clever people. So the bigger circle will be clever people. Mathematicians will be within the clever people. So mathematicians become subset of the clever people. Then we know Ellie, Doe, and Casey are elements in the identified subset. Ellie is a mathematician. So Ellie is a mathematician, so he will be within this mathematician's circle. Therefore, Ellie automatically become a clever person. Then Doe is a clever person, but Doe is not a mathematician. So Doe will be within the clever circle, but Doe will not be in the mathematician circle. Then Casey is not a clever person, therefore Casey is outside the clever circle. And because Casey is not a clever person, Casey can neither be a mathematician as well. So Casey is outside. Negation of statements. Negation of statements is usually formed by using the operators not, denoted by this symbol. For example, P, all birds fly. So the negation will be not all birds fly. So this is denoted by negative P, like this. That is negative P is either not all birds fly or neg P. It is not the case or it is not true that all birds fly. We notice that for any statement or any true statement, the negation is false. And for any false statement, the negation is true. If you negate a statement, you get the original statement. That is already negated. If you negate a negative statement, the statement is already negated. So when you negate it again, then you get a positive or the original statement. So when we take these following questions, the first one says, P, all prime numbers are odd. When you negate this one, because not all prime numbers are odd. And that's a true statement because 2 is a prime number and 2 is not odd. The second one, 17 is congruent to 2 mod 3. When you negate this one, because 17 is not equal to 2 mod 3. And that's a false statement because 17 in mod 3 will give us 2. So that's a false statement. Third one, 7 belongs to factors of 56. When negation becomes 7 does not belong to factors of 56. And that's a false statement. So we can guide our students to know that if A belongs to set A, then A does not belong to complement of set A. We can see that complement of a set is the negation of the given set. That is, a negation of a statement about A, about a set A, is a statement about A. So let's illustrate these questions. A success is a member of mathematics club. So if success is a member of mathematics club, then the union become mathematics members or people. Then M become members of the mass club. So the union become club members or people. Then M become the members of the mass club. So if success is a member of the mass club, if success is a member of the mass club, then success is not a member of mass club, because here we want to negate the statement. The question says negate each of the following statements. So success is not a member of the mass club. If success is not a member of the mass club, then success will not be in the mathematics club or the mathematics circle. The next question is, math students do well in English language. So negation become math students. The math students do not do well in English language. So negation become math students do well in English language. So universal is U set of students or students. Then our E become students who do well in English language, and M, which is math students, will be within the English language circle. Then our next question was, P is divisible by 5, or P is not divisible by 5. So our negation become P is divisible by 5. So here we want our universal become numbers. Our set is numbers that are divisible by 5, and P will be part of our set. This brings us to the end of this session. In this session, we look at the logical reasoning or logical statements in the form of true or false simple statements and their negations, and represented them in the Venn diagram. Thank you.